Hello everyone, welcome back to this channel, and today I will be talking a little bit about the sum of two periodic signals. So let's say you're given two periodic signals. Let's say x1 of t is equal to cosine of t, and x2 of t is equal to cosine of the square root of t. And if you look at the previous video, I basically went through how to basically find the period in both cases, right? So let's say x1 of t, the period is, the formula for finding the period is always 2 pi a variable over omega naught, right? So that it will be t1. And x2 of t, the period, it will also be something similar to that, which will be 2 pi, let's call this k over omega, omega 01, right? So omega naught, we know in x1 is equal to 1, right? And we know that omega 1 or 01 in x2 of t is equal to square root of 2. And therefore we know that t1, right, t1 is equal to 2 pi t over 1, which is basically 2 pi t. And we know that t2 is equal to 2 pi k over square root of t. Now, you may ask yourself, why am I going through this? Okay, I'm going through this because lately I've been getting a lot of questions related to, basically adding two periodic signals. So the question is, what happens to the fundamental period if you add two periodic signals? So let's say we have another signal, x3 of t, and in x3 of t, you're basically adding x1 of t plus x2 of t. Now the question that emerges is, since these two signals, right, x1 of t and x2 of t are basically periodic with these periods, will x3 of t be periodic? That is the main question, right? Will x3 of t be periodic? Okay, now in order for x3 of t to be periodic, both x1 of t and x2 of t must, okay, I'm going to underline this, must both share a common repetition value. Okay, they must, both cases, share common repetition value. Okay, so which in turn means that two periodic signals, when they are adding each other, will produce a signal. In some cases, it will produce a signal that is periodic, and in another cases, they'll produce a signal that is not periodic. So now let's see this. All right, so in order to do this, we basically said in order to check whether x1 of t and x2 of t have common T1. Let me change it to T1 because we have like T2 T's and sometimes it gets confusing. So in order for us to check whether these two signals, which is x1 of t and x2 of t, to check whether they both share a common repetition value, we will basically set the periods of x1 of t and x2 of t to each other. So the period of x1 of t is 2 pi t, and the period of x2 of t again is equal to 2 pi k over the square root of 2. Now, so this and this basically cancel each other, and now tk over t1 will basically be equal to the square root of 2. Again, since k over t1 is an produces an irrational value of square root of 2, x3 of t is not periodic. Okay, it's not periodic because getting an irrational value of square root of 2 means x1 of t and x2 of t basically do not share common repetition value. In order to have a common, the value that you should be getting is a whole number, not sort of an irrational value. Okay, so that in short means that this is not x3 of t is not periodic. Okay, this will mark the end of this video. I hope you guys enjoyed this, and I hope this enlightens your understanding, and please do not forget to subscribe. Thank you.